Hey everyone, welcome back to Intellify. It's your friend Apurva and I'm back again with some more NCRE problems of the chapter Sound. So we have the question here. Basically, it's numerical. So a stone is dropped from the top of a tower 500-meter high into the pond of water at the base of the tower. So we need to find that when is the splash heard at the top. And the question has already given us the g, which is the gravitational acceleration, as 10 meter per second square, and the speed of the sound as 340 meter per second square. The question has already given us the height of the tower, which is 500 meters. The velocity of the sound is 340 meter per second. The acceleration due to gravity, or you could say the gravitational acceleration, is 10 meter per second square. And I'm taking the initial velocity, that is u, of the stone as 0. Why I'm taking the initial velocity of the stones as 0? Because the stone is being dropped by the thrower. So there's no external forces applied by the thrower to the stone. So we can assume that when the stone was in the hands of the thrower, so it was at rest position. So when an object is at the position of rest, its velocity becomes 0. So that's why we are taking the velocity of the stone as 0. So now the question hasn't helped me by providing me the time taken by the stone to reach the ground, or you could say the pond. So therefore, I'm taking the time taken by the stone to fall to the base, a tower base, as T1. So in order to calculate this time, I'm using the second equation of motion, which is S is equals to UD plus half AD square. So I have written the equation as S is equals to UT1 plus half GT1 square. I have substituted my A with the G, because here we are using the gravitational acceleration. So now I'm substituting all my values of S, U and G, which are 500, 0 and 10 respectively. So after calculating my these equations, so I would be having my answer as T1 is equals to 10 seconds. So now I got the time taken by the stone to reach the ground. Now what I'm going to calculate is that the time taken by the sound to reach the thrower. So what I'm going to do, I'm just simply using a formula, that is time is equals to distance divided by speed. So which is 500, that is the distance, divided by 340, which is the speed of the sound. So I'm getting my answer as 1.47 seconds. So the total time taken by the sound to reach to the thrower's ear would be T is equals to T1 plus T2, where T1 stands for the time taken by the stone to reach the ground, plus T2, which is where T2 stands for the time taken by the sound to reach the thrower. So that is 10 plus 1.47 seconds. So my total time becomes 11.47 seconds. So yeah, that's all for today. See you guys in the next video with some more questions.